Question 11 provides us with a question about the height of a plant. We've been given the expression involving E and time as to the height of the plant as it grows, T being years. Okay, so let's look at part A first. Find the height of the plant was first measured. So it was first measured when T was 0. So we've got to substitute T is equal to 0 into this equation and work out what H is. So here's the situation. T is equal to 0, and we've got to substitute it into here. Anything raised to the power 0 is 1. So therefore, H is equal to 2.3 minus 1.7, which is equal to 0.6. And this is meters. And that's the answer to part A. Part B, show that exactly 4 years after it was first measured, the plant was growing at approximately 15.3 centimetres per year. Remember, our height is in meters, but we'll come to that problem later. Now, we're talking about a rate. That means how H is changing with respect to time. So we're going to have to differentiate this function and then substitute that T is equal to 4. Differentiating a constant, we get 0. Differentiating the E term, we can effectively put negative 1.7 out the front and then just concentrate on the differential of e to the negative 0.2t. Now, the differential of this e term is the e term exactly as written, and I've left a gap, and this is where you need to differentiate just the power with respect to t. This is the chain rule in action. So this is another negative 0.2, which is inserted into here. So this is equal to 0.34 multiplied by e to the minus 0.2t. And that's a perfectly good point to now substitute t is equal to 4. And if you pop that into a calculator, you get that dh dt at t is equal to 4 is equal to 0.15277. That's meters per year. And if we multiply by 100 to get this to centimetres per year, we get indeed the answer that they wanted, which is 15.3 centimetres per year. And that is to one significant figure. Let's look at part C. According to the model, there is a limit of the height to which this plant can grow. Deduce the value of the limit. So if we look at the second term, this is negative 1.7, and I'm going to put the negative power and use it. This becomes e to the 0.2t. So we can say as t becomes very large, this whole term tends to go to 0. So the plant height will tend to equal the value that remains, which is 2.3 meters. And that will be your answer.